All right, everybody. We are kicking up some review here for the midterm here. Some of these I've already done with you guys, but I'm going to go through each problem anyway. Uh, so we'll just go through as quickly as possible because I know we got things to do. But feel free to scrub around on the video and get where you want. Don't forget to hit the like and subscribe, and I don't care. I'm not getting any money from these. Anyway, let's do number one. Guy went on vacation. He's got some couple of shirts and four different options for pants. And because there's some kind of like different things, I like to just put little spaces and say how many options for this one, how many options for this one. There's no overlap there. Just multiply them. So he's got 8 options. Okay. What's the new amount when 590 is increased by 140%? Okay. So you got to think about like an increase of 0% is nothing. An increase of 100% is essentially doubling it. So we're going to take the 590 and we're going to multiply it by the 1 plus the 1.4. In other words, it's not like a double. It's I want 1 to get what I had to start with, then I want to increase it by 140%, which as a decimal would be 1.4. And so as you go through and punch that in the calculator, you get 1416. And when you get an answer like this, just double check and say, hey, if I had $590 and I want it to be increased by 100%, 140%, would that make sense? Well, it's got to be more than double, and that seems legitimate there. All right, find the combination of 10 objects taken 2 at a time. Well, that's easy. That's 10C2. Okay, and you could just put that in the calculator if you want to. That'd be under math and probability, NCR, and just put 10 on top, and whoop, whoop, there we go. 2 on the bottom, bam, 45. Okay, and the formula is not bad either. That'd be 10 factorial over 10 minus 2 factorial, which would be 8 factorial, and 2 factorial. And when you write this out, this is 10 times 9 times 8 factorial. Just cut it off when you get to match the bottom. And then 2 factorial is just 2 times 1, so just I'll just leave it like 2. And these cancel out. These 8 factorials will cancel. And so you get 10 times 9 is 90 divided by 2, 45. But calculators seem to do a pretty good job too. All right, you got a straw in here at an angle. Let me start this one over because we've done this before. But the key on this one is to realize this is a 60-degree angle. And if it's a 60, and it's kind of given that this is a 90-degree angle or here, and so this would be a 30. So you have a 30, 60, 90 triangle. The hypotenuse of a 30, 60, 90, this straw here, is going to be is 20. And so what I would do is label all your sides. This would be x, this would be 2x, and this would be x rad 3. So remember that formula for the 30, 60, 90. This is double. The 2x equals 20. Just say 2x equals 20, so x equals 10. Okay, so that means this is 10, and this is just 10 rad 3. And that's really all you need there. What did they even ask, though? I should probably figure that out. How tall is the glass to the nearest centimeter? So just do 10 times rad 3. Oops. 10 times rad 3. I haven't used this calculator in a minute. 17.3, or 17 to the nearest centimeter. Okay. Good stuff. You got a bag. Of course you do. It's got 4 red and 12 blue marbles in there. What's the probability of picking out a red marble, keeping it out of the bag, and then picking out another red marble? So you can treat these like 2 separate events, but these are not independent events. Okay, so this is the probability of A, right, times the probability of B given A. So this is one of our newer formulas here. Make sure you got this down. So the probability of A, the first event, is getting a red marble. That's 4 out of 16. So that's just 1/4 or 0.25. And then, so the probability of these two things happening is this one, then this one, given that the first thing happened. So now suppose you got your red marble. What are the chances of getting a blue marble second? And that would be 12 over, so there's 12 blue ones in there still, but not 16 anymore, there's only 15. So your chances went up. And I don't usually like to mix decimals and fractions, but whatever. 0.25 times, parentheses, 12 over 15. Oops. And that gives me 0.2 and 0.2. Is that right? 20%. Did I do that right? Shouldn't be that high, should it? Oh, I didn't read it right. It says picking out another red marble because I just assumed it was going to go blue next. My bad, everybody. So this is 3. There's only 3 in there, 3 out of 15. And so 3 out of 15. So 0.25 times 3 out of 15. Sorry for that. And bam, 0.05. 0.05. That's more like it. All right, moving on, number 6. If you can't handle this one, you need to go back to Algebra 1. So I would distribute first. This is 9r minus 36 equals 3r plus 15 plus 3r. Now that you've distributed, you're going to simplify each side, combine like terms. This is 6r plus 15 equals 9r minus 36. And we're going to get numbers on one side, get the other stuff on the other side. And I like to do it in one step sometimes. Plus 36. All right, so then we'll add those up. These will cancel, and 15 and 36 is 40, 51 equals, and then 9 minus 6 is 3r. Now we'll just divide. Okay, so r is 17. Woo, 17, so fun. All right, good stuff. Adding, I love these little symbols they come up with here. We'll try to ignore them here. Anyway, we got a plus going on here. We're going to add this thing and this thing, which plus is the easiest one. You just combine like terms. Just be careful when you're moving things around. Remember the negatives belong to those. I would smatto, but it's just really not much point in that right now. If you had this, if this was a negative, then you would smatto. So you'd make that a plus and then change the signs of everything to the right. But in this case, yeah, we good. Okay, so I've got 5x squared and 2x squared. Those are like terms. I've got negative 7x and negative 2x. And I've got, even though they're different orders, totally good to go. So this should be a gimme. 3x cubed doesn't have anybody to combine with. But then we're going to go in order here. So this would be 7x squared, and then minus 9x, and then minus 3 when you're done. Okay, good stuff. So much fun. Let's move on down. Okay, multiply. This is more at my speed here. When you have a trinomial times a binomial, I would recomiendo, I would recommend this, your little grid, right? Remember the grid? That helps you keep everything straight, make it real organized, and you can recognize your common terms and things. So do a and negative 3 here, do 2a squared, 7a and negative 2 here, and now just fill in the box. How hard is that, right? So this is 2a cubed, and this is 7a squared, and this is negative 6a squared, and this is negative 21a, and this is be 6 down here, negative 2a. Now once you've done that, just look on your diagonals, check your diagonals, because you should quite possibly are able to combine like terms on the diagonals. So when I look to combine like terms, I get 2a cubed, and this would just be 1a squared, so plus a squared. And this would be minus 23a and plus 6. Happy birthday. Killed it. All right. Next up. We're talking about this one here. This is kind of interesting. It says, what's f times g? This is telling you with the two functions, you're going to multiply them. So plug in a -4 and then multiply the two things together. However, you might have noticed this. Your domain, in other words, all the possible value of x for g of x is positive integers. You cannot plug -4 into g of x. So you can't do it. Cannot do it. Yeah, can't do it. All right. Solve. Ignore those funny things here. This is just showing you that it's a system. In this system of equations, we are going to look at, I would just clean these up, honestly. There's a number of ways. It doesn't tell you how to solve it, and you can just do whatever you want with it. What would I do? What would I do? I would be tempted. Let's convert this one a little bit. So I'm going to multiply everything by 6, solve both for y. Kind of at a loss of what's the best technique for solving this? I think I'm going to multiply this one by 3 over 2 on both sides. Now watch why I do that, okay? Because 3's cancel with 3, 2's cancel with 2. This gives me x. Awesome. Now this one, cancel the 2 and the 2, and you're left with 3y. So now I'm down to like a single isolated value. That's pretty easy to do substitution method. So once you know x is equal to 3y, why not plug it in everywhere there's an x in the other problem? So -2 plus 5y equals 2 times, now here's where we plug it in, substitution part, 3y. Well, this is just easy as can be. This is 6y equals 5y, and -2. We'll subtract, and we just get y equals, and then -2. Once you get y is -2, watch how easy this is, guys. You ready? Y is -2, so plug it back into the box you made in the beginning. So x equals 3. Now, well, you know y already, so just put -2, and it's 6. So if you wrote it as an ordered pair, it'd be 6, -2, and we are good to go. Oh, -6. I almost missed it. -6, -2. That's more like it. All right, good stuff, good stuff. And honestly, like, I just kind of had a half typo there, but I should check those. Always check them back in one of your originals, and I would probably have used, yeah, I might have used, I'm not sure which one, I might use both. So if you got time to check them, which you should, you have a long midterm here, 2 hours to do it. Why not check your answers? Just plug them back in and see if it worked, right? Not bad. All right, Paul, let's go, Paul. Recorded the following high temperatures in degrees Celsius for each day at, okay, it must be outdoor temperatures, not his own temperature. He's fluctuating too much. He's got the Rona. All right, calculate the mean, median, mode for temperature measurements. There's a billion ways to do these things, but mean, I don't think I would probably, I mean, you can put them all in your calculator and hit a button and it would do all those things for you. But for seven data points, I just do it by hand. 12 plus 14 plus 19 plus 22 plus 16 plus 16 plus 13. And we'll just divide that by 7 and, oops, not times 7. 112 divided by 7. There we go. That's 16. So our mean, 16. The mean is 16. All right, let's look at the median. Median is the middle number if you put them in order. So I'm just going to go one by one. I'll go, and in this case, it'd be like the fourth number, right? So there's 1, there's 2, 3, and there's number 4. So 16 is our median median as well. Get out of here. And the last one is asking for mode. Mode obviously is most often. Mode is most often, and the one that appears the most often is also 16. So 16 is all around. All right, number 12. Let's solve a system. One of the best ways to solve a system with 3 rascals in there is to do what I do and turn them into matrices. So let's do a matrix. So you have your variable matrix. You've got your and coefficient matrix first, and this equals your solution matrix. So let's be -2, 1, 0, x, y, z, and 1, 1, 1, 4, 2, -1, 2, -1, 4, and now you're good to go. Let the calculator do your evil bidding from this point forward. Now, the key is to understand like how to break this down. Okay, so the calculator can do a lot, but you still have to have the brains behind it to make it work. Okay, so go to matrix, and we'll go do our 3 by 3 here. Oops, told you we need brains. I ain't got mine right now. All right, we'll go to matrix edit first, and in matrix we'll just go 1, enter, 1, enter, 1, enter, 4, 2, -1, 2, -1, 4, and we're done. Okay, and we'll also go to matrix edit B, and we'll just put -2, 1, 0. Done. All right, now you've got matrix A and B, and the key on this one, let me show you the formula, okay? This is A, this is X, the unknown matrix, and this is matrix B. So A times X equals B. How do you get X by itself? Just like any other thing, we're just going to solve it, and we'll be good. So how do you get rid of A? You multiply by A inverse. You can't divide in matrices, so you have to do A inverse out front. If you do A inverse on the front of this one, you have to do A inverse on the front of this one. It's got to be in the front. So the formula for X, these sort of cancel each other out, so to speak, give you the identity, is A inverse B, and this is what you're going to type in the calculator. So let's do it. So go back to your screen, main screen or whatever, and you're going to type A. So matrix. Now instead of edit, you're going to names. So I'm going to pick A, and then inverse is right where the matrix button is. So the -1, X to the -1. So A inverse, and then now I do matrix again. Pick B, bam, and I get 1, -2, -1. Right now. Okay. Yeah. So that's pretty good. Not too bad. All right. Good stuff. Let's keep it going. These are a little distracting here, so let's pull these out. All right, so let's multiply these. Now, when you're multiplying, remember what I say, always just draw a line across. But if you can factor this one on the right or factor something down low, you're going to be able to cancel things out, and this is not going to be as complicated. So factor first, so let's do that. X plus 9, that can't break down anymore. Make a giant bar. Okay, leave that alone. All right, this one can pull a 3 out, so that's good. 3 times x squared minus 10 plus 9. That looks right. Okay, and then all over, and then this will pull out 2 x's, so x squared, and then x minus 9er. Yeah, that looks good. All right. Next up, we're going to break down the numerator. So it's going to be x plus 9. This pen is not doing well here. I might need a new one. So x plus 9 over, and then x squared times x minus 9 Okay, and let's break this one down. Let's leave the 3 here. And I'm just going to see if I can cut this into 2 things. So let's see, x squared and 9. So signs are the same. So 9 and 1, I guess. So it'd be x minus 9 and x. X minus 1. Wild times over here. All right. What we're going to do is cancel things out. So look, can cancel that and that. The 3 doesn't have anybody you can cancel with. I don't see anything else to cancel. So just write x. Man, what's wrong with this pen? I don't know if it's PDF Expert or the pen, but pen it might need to retire. Anyway, so it's going to be x plus 9er times 3. Well, let me put the 3 out front. That might be better. 3 out front. And then x minus 1 all over x squared, like that. And that's actually a pretty good answer right there. I would leave it like that. Okay. All right, moving on. Moving on. All right, this one says we want to write a quadratic function that has those zeros. Now, if something has, this is the opposite of like I give you the function and you tell me what the zeros are. What would that process look like for you? Well, first you'd factor, right? You'd set it equal to 0. You set each factor equal to 0, and then you'd solve it. So this is the opposite. First you set each of those zeros equal to x. Now undo those. The trick on this one, I think, is this right here. To get rid of the third in the denominator, don't add 2/3 to both sides. Instead, multiply both sides by 3 first. So you get 3x equals -2, add 2, and then you get 3x plus 2 equals 0. There's a nice looking factor for you, okay? This is the same way. You're going to subtract 3. X minus 3 is 0. Now you've got 2 factors. Just write it like that. You don't even have to multiply it unless I told you to. You could leave it like that, okay? There you go, f of x. Number 15. What's the relationship between the graphs, these two graphs? Third cousins, twice removed. So here you go. What do you notice? Does this even work anymore? All right. You notice the slopes, right? You see 25 and 25, so you could just say they are parallel. Okay. And you could say, you can even add in that one is shifted up from the parent function 2 units. You could say the other one is shifted down 7 units if you wanted to get into that, but all they're really looking for is parallel, I think. Is this point a solution of the inequality for number 16? If it is a solution, when you plug it in, it will work. So put 4 in here for y. Is 4 greater than -3 times 5 plus 3? Let's see if it is. So 4, is it greater than, this is -15 plus 3, and -3, whatever it is, -12 is definitely less than 4. So is it a point of the thing? You just say, yeah. Okay, good stuff. All right, this one's kind of fun, and I did this one in class. I think both classes I've done this one, so I won't spend a lot of time on it, but I'll just review it in case you need to practice again. Find the value of a k. So when you want to find the distance formula, you can use Mr. T's like abbreviated formula, which would be like, you know, delta x squared plus delta y squared, square root of that gives you your distance. But when they need you to find these, you actually kind of have to use the old school formula, x squared, or x2 minus x1 squared, y2 minus y1 squared. So I just wrote the formula first. So just familiarize yourself with this. Now, just label all your things if you want. You could say this is x1, this is y1, x2, y2, and this one would be my distance d. So plug in all the numbers. That's all I did here. There's 1 number, 2 numbers, 3 numbers. Okay, but I just put a k where that x2 is because or x1 is because I don't know what it is yet, and that's fine. Now let's break it down. Okay, how do you undo square root? With a square. Square both sides. 25 equals all that mess. Okay, now break it down a little further. -4 squared becomes 16. Awesome. And I just left this thing alone. I'm trying to get k by itself here. So now moved 16 over, subtract 16 from both sides, I got 9. Now, this is the critical step. When you undo a square, anytime you undo a square and introduce a square root, you always account for the plus or minus because you don't know if what was in those parentheses getting squared. That could be positive, that could be negative, we don't know. But once you squared it, it turned positive. So we have to account for the positive and negative answers. So put plus or minus radical 9, which becomes plus or minus 3. Okay? Now, the last step is to say because it's plus or minus, split it into two cases. Might have been plus, might have been minus. Do two different problems here. I'll add 4. Make it 7 equals negative k, so positive k would just be negative 7. Okay, and then the other option is add 4, and I get 1 equals negative k, so k equals negative 1. So there's the two options. It makes sense that there'd be two options because it's like 1 point's here, and you could have it be 5 away. If you didn't know the x value, it could also be this x value and also be 5 away. So there's two options there. All right, so much fun. Let's go to the next one. Number 18. Tickets to a concert cost $25 for the lower level and $10 for the upper level. All right, so let's, first thing I do, let x equal and y equal, okay? So whatever that is, that's all we got to worry about. Lower level and upper level tickets. So lower and upper. Okay, so this, and it really is the number of tickets, I should say. Okay, so the number of tickets for upper level and the number of tickets for lower level. So I'm gonna let X be the one. All right, so tickets for a concert. Says they can spend up to $800. So however many tickets the lower level tickets are, so it's $25. So 25 times X, so per ticket. And then plus $10 times Y, okay? And that's going to be not equal to, but you can do up to that. So this can be, has to be less than, or could equal $800. So there's one of your graphs. The other graph says they plan to buy up to 50 tickets. So this is X plus Y. It has to be less than or equal to 50, okay? Now you just graph those bad boys. And I've said you can use Desmos if you prefer. That's fine. So you can use that to sketch the graph. I don't know if we want to bother with that now or not. Might as well get some Desmos practice in. Okay, so this would be, it was X plus Y is less than or equal to 50. Okay, and then the other one was 25X plus 10Y. Whoa now. Come on, pencil. I'm telling you, I need a new pencil. All right, 25X plus 10Y. Wow. All right, is less than or equal to 800. Okay. Now let's zoom out and see what the picture looks like. Nice little polygon. If we were doing lesson 55, we would find the vertices, those corners, and we would test them out. So there's one, there's another one, and you could use those little critical points and see what all those are about and plug them in to your objective function if we are doing that kind of problem, but we're not, so on we go. All right, next one. Let's do two more and we'll take a break. All right, so here we go. Number 19, pretty simple. We just need to use the conjugate. So conjugate is going to be 7 minus 3 radical 2. And if you do it on the bottom, oops, you get to do it on the top as well. So 3 rad 2. And now it's just a little matter of how good are you at foiling. Now the bottom, you don't need to worry about the O and the I from FOIL. Just do the first and the last because O and I will cancel each other out. Save some time. Just clean the bottom up real quick. This would be 7 times 7, 49. And then 3 times 3 is 9. So it's going to be minus, because 1's negative, minus 9. And then rad 2 times rad 2 is just 4. 9 times 4. Awesome. Now up here, do FOIL. First times first, 21. Okay. Outer is going to be minus 9 rad 2 Inner is positive 7 rad 2. And last is rad 2 times rad 2 is just 2. Did I screw that up down there? I did down there, didn't I? Rad 2 times rad 2, that should have been just 2. You guys got to yell at me if I make a mistake like that, please. Leave it in the comments. No, don't. I'll be so embarrassed. Anyway, so the inside 7 rad 2. And then last, which is just going to be rad 2 times rad 2 is just 2 times negative 3. Okay, so this will be negative 6. And then we'll just clean this up as much as we can. So 49, 9 times 2. Let's do the multiply first, right? So 49 minus 18. Can't type, there you go. Is 31. So 31 on the bottom. And on the top, it's going to be, let's see, 21. I'll do minus 6. It would be 15, of course. And then negative 9 rad 2 and positive 7 rad 2 is going to be minus 2 rad 2. Okay. And that looks pretty good to me. All right, let's do one more, and then we'll do a breaky break. Okay, these are easy. Best thing to do when you have complex fractions here is look at all your denominators and multiply everybody by something that will knock out all the denominators. So if I do AB here and AB here, well, I have to do it everywhere because you can't just be selective, right? There we go. So ABs are canceled. A goes with this one, that's gone. Okay, good. This B is gone with this B. Awesome. And that's about all you can do for canceling. So this would just be 4B plus 6AB all over, and then this would be negative, let me do 9AB minus 3A. And then you look for anything you can like maybe factor that would cancel with somebody, but there's really nothing to do there. You can pull A's out in the front, 3A out of the one, and throw some B's out of the other one, but I don't think there's anything that's going to reduce that any more than it is. Let's leave it. All right, good stuff. Let's take a little break. Good work.